All right, well, it's been a week since you've done any of this stuff, so hopefully you'll remember it. I bet you it'll come back to your memory, and you're going to like, oh, yeah, it was like yesterday I did this. Do you think it's going to, the way it's going to be? Well, your brain doesn't hurt just because you don't, it's probably because you don't use it.
So brains don't actually have pain receptors, so like there's no nerves in the brain.
Right, that's true because I've seen they have like open brain surgery, and the person's like wide awake.
Yeah, like on house.
On House? I don't know. Saw it on YouTube. Saw it on YouTube.
No, yeah, make sure they're still alive.
Yes, because if they did something wrong, they would die. So they're awake the whole time to make sure.
All right, here we go. See, I don't really watch those shows, so I wouldn't know. All right, let's change this around a little bit. Let's make this 5, 12, 13. All right, I changed that around a little bit. All right, so the first question, it's a three-parter. You got to get all three right to get it right. Okay, so number 1 on the quiz is going to look something like this. Not going to be exactly these numbers, but it'll be close to it. And they're going to ask you to find each trig, or the 3 trig ratios, and they say find the exact value. The exact value. So don't put it into a calculator. Don't get any decimal approximations. These don't approximate anyway. Well, I don't know. Maybe they do. But anyway, find the exact value of each trig ratio. I'll put the 3 trig ratios. It's a 3-parter, correct. And that's the 3 parts. We'll call it A, B, and C. Okay? So what are the 3 trig ratios that we learned? You learned SOHCAHTOA, right? So what does that stand for? The what? The sine. And by the way, we're going to find the sine of angle A. We're going to find the cosine of angle A. And then we're going to find the tangent of angle A. Okay? First thing I do if I'm going to use angle A, I like to put a little arc right there just to remind me that that's the angle that I'm using. All right, I think that's kind of helpful. All right, the sine of A. Do you remember what did I just say? What was that little device that we learned? So, what? Ka. And then toa. SOHCAHTOA. Remember that. Okay, if you remember that, you can do this problem. You should be able to. So the sine is what? Opposite over hypotenuse. So look at here. Angle A is right here. Which one's opposite? Which one's hypotenuse? So it's 5 over what? 13. Okay? That would be your final answer. That's right. Does not reduce. All right? So it's good the way it is. That is an exact value. All right? And then the cosine, what's the cosine? Adjacent over hypotenuse. Right there, isn't it? All right? So which one's adjacent to angle A? No, settle down. Okay? If you're going to answer a question, you can talk. What's adjacent to angle A? 12. All right? And what's the hypotenuse? 13. So this is 12 over 13. Super easy. You don't need a calculator. Don't need to show any work. Don't have to work anything out. All right? You just got to know your trig ratios. And the tangent is what? What over what? Opposite over adjacent. So opposite is 5, adjacent is 12, and there you go. Now, if I gave you numbers that you could reduce, you need to make sure you reduce them, okay? But in this situation, there's nothing that reduces. Would you agree? All right, so that's good. That's your answer. Basically, these are your 3 answers right there, okay? So that's number 1. You got to get all 3 of them right to get number 1 right. All right. No. I already give you half anyway, right? So that'd be silly to give you partial credit on something I already give you partial credit on. No, that'd be horrible. All right, let's do another triangle, and they're going to ask you some other stuff about this. Again, these are right triangles. You can only use these trig ratio things when you have right triangles. We will this week learn how to solve some things that are not right triangles, but we're not going to use these regular trig identities. We're going to learn something called the law of sines and then the law of cosines. All right, it's a little different than this, but you still use sine and you still use cosine. But you can solve for missing things that you wouldn't have been able to solve for unless you knew those particular things. All right. I'm not going to use the numbers I use on the quiz. I don't know. Let's say that's 8 and say this is, 20. And that's x. And this is, let's call that y, sorry. If you already wrote it on there. So this is angle y, this is angle z, this is angle x. I could have called them anything, but that's what we have there. So number 2 on the quiz says find angle x. Number 3 says find angle z. And then number 4 says find side y, or y equals. Yep. Okay? All right, so where do we even start? What are we finding first? X. Yeah, we could do y first, couldn't we? Okay, and what would you use if you're going to do that? And this one says, now the other one says give me exact answers. This says round to the nearest tenth. So we are going to be using a calculator then. So make sure you know how to do this stuff on your particular calculator. There's no sharing calculators. You got to come with one. If you don't have one, I'm not letting you borrow one. Everybody hear me on that, right? Okay, you must come with calculator. I'm telling you, you won't get these right. There's no way in the world you can get this right if you don't have a calculator. Okay, so you must have a calculator, and you must know how to use the calculator. So don't just borrow friends at lunchtime. Oh, can I borrow your calculator? I forgot. And then you get it, and you're like, ooh, this is different than mine. I don't know how to use this one. Because some calculators, you do them different ways, right? You find the sine, cosine, tangent a little differently depending on what calculator you have. So make sure that you know what calculator you're using. All right, angle x. Let's do this. What I say we're going to do, let's solve for y first, okay? Might as well do that first. So how are we going to solve for y? Pythagorean theorem, okay? So let's do it. It's y squared equals what? 8 squared plus 20 squared. Now I just made these numbers up. So I'm going to put it into a calculator myself. You know what you're going to do, right? You're going to get rid of this, take the square root of this. All right, so I'm going to go 8 squared plus 20 squared equals, that's 464. Take the square root of it. Comes out to a decimal number, which is fine because we're going to round it to the nearest tenth anyway. Agreed? Yes. All right, so 21.5 is what I got. Is that what you got? If you round it to the nearest tenth, because it's actually 21.54. Does that 4 round that 5 up? No, it doesn't, so you just keep it 21.5. So that would be your answer right there. Has to be exactly 21.5, okay? Because it says round to the nearest tenth. So if you put that in your calculator, that's what you should get. All right, now let's solve for angle x and angle z. Let's solve for this. Now, what's two sides do they give me? Now, I had to find this, but again, this is a rounded number, isn't it? Right? We rounded it to the nearest tenth because it's 21.5406592, blah, blah, blah. All right, so this is a rounded number, so it'd be nice if I could solve for angle x with the numbers they gave us originally. So let's use this 8 and this 20. So what trig function am I going to use if I'm solving for x? What is the 8? 8 is opposite, right? And what is this? It's adjacent. What uses opposite and adjacent? The tangent, that's right. So that's how we know which one to use. The tangent of what? Angle x is equal to, let's move this out of the way. So it's equal to what? 8 over 20. Do you remember how to solve for x? It means I have to get rid of the tangent. How do I get rid of a tangent? I don't divide by the tangent. What do? Take the inverse. See, you guys know this. take the inverse tangent. So this is how we write inverse tangent. Remember that? Tangent to the negative first, the inverse tangent of 8 over 20. Now again, make sure you know how to put this into a calculator. Just because you have a calculator doesn't mean you're going to get these answers right. You have to know how to put it in there. And it depends on which calculator, because you can do this two different ways depending on the calculator that you're using. If I have a scientific calculator that looks similar to this is how I would do it. I would go 8 over 20, 8 divided by 20, and that gives you 0.4. And then I would go second function tangent, and that gives me 21.8. And that's an angle, isn't it? Okay, that's this angle right there. That's what I just found. So this is 21.8 degrees. If you have a graphing calculator, who's got a graphing calculator? I see graphing calculators. Tell me if you have a graphing calculator. Is that, no? Johnny, don't you have a graphing calculator? Like a big old, yeah, it's a graphing calculator. Okay. You didn't know that was a graphing calculator? It says it right on the top of it, doesn't it? I think it does. All right. So anyway, here's how you do it on the graphing calculator. You hit second function tangent first, and then this will pop up on your screen, tan to the negative first. So you hit second function tangent, it'll automatically give you a parentheses, then you put 8 divided by 20, close the parentheses, hit enter, and it should give you 21.8 degrees. Make sure your calculator is in degrees, all right? Everything we've done so far, and I don't think we're even going to use radians this year. Maybe in Algebra 2 we might get to that. But make sure it's in degrees, all right? And then you should get 21.8. Make sure you did that. Did everybody try that on their calculator? Did everybody get 21.8 degrees? If you didn't, you haven't done enough. All right, so try it right now. Make sure you get that answer. All right, and I'm harping on this so much because I've seen so many kids get to the quiz or the test and like, Mr. Hamrick, I don't know how to use this calculator. I just borrowed this from Johnny and it doesn't work the way my calculator works. All right, so you need to know how your calculator works and make sure you bring the calculator that you have right now, bring it to the quiz tomorrow. All right, let's find Z, this angle right here. So again, let's use the same two sides, the 20 and the 8. But this time, the 20 is opposite and the 8 is adjacent. So I'm still going to use tangent, but I'm finding the tangent of what? Angle Z is equal to the opposite. Which one is opposite angle Z? No, 20 is opposite angle Z. 20 is opposite. And then what's adjacent to angle Z? The 8. Some of you might be thinking, well, why can't I use sine and cosine? Because I've got the hypotenuse. But remember, this is an approximation, 21.5. Don't use the approximation if you can get away with using the numbers that they give you. And you can. You can use the numbers that they gave you originally. So let's make sure we use those. All right. So what do? We solve for Z. So what's Z? It's the inverse tangent of 20 over 8. So that's what you're putting into your calculator right there. Again, make sure you know how to do that. On my calculator, I go 20 divided by 8 equals, that's 2.5. Then I hit second function tangent, and I get 68.19. If I round it to one decimal place, what would that be? 68 point what? 2. 68.2. And this is an angle. We just found that angle right there, angle Z. So put a degree symbol with it. All right. If you're finding an angle, put degrees. Make sense? All right. So that's numbers 2, 3, and 4. The numbers will be different. Okay, I just made these numbers up for us, but the numbers will be different. But the style of problem, the way you work the problem is exactly the same. Everybody good so far? Let's do another one. This one's a little bit different. So this time, they actually give you an angle. They say that's 47 degrees, but they only give you the one angle. And they only give you the one side. But that's good enough. That's enough to solve for what we need to solve for. All right, so this is numbers 5, 6, and 7. If I can write here, there we go. 5, 6, 7. So 5 said, well, let's put some letters here. That would be helpful. That's A. That's C, the right angle. That's B. Yep, there we go. That's everything. So we just got to find the missing parts. So let's find angle B. Let's find side B. And let's find side C. Everybody understand that little b means it's side. If it's capital, it means the angle. All right? Let's do angle B. Oh, angle B is super easy. Don't even need a calculator for that. How do I find angle B without a calculator? Yeah, just 90 minus what? 47, which would be what? 43? Be 43, wouldn't it? Wouldn't it be? Yeah. Okay. All right. Everybody with me on that? Yeah, that was easy. So that's 43 degrees. And that's exactly 43. All right. So I could use that angle if I wanted to. Side B. This is what I got to solve right there. Now, I could either pick the 43 or I could pick the 47. Doesn't make any difference. Let's just use the 47. That's what they gave us originally. So let's use that. And this is a 9. I didn't make that long enough. There we go. And I want to solve for B. So look what, according to angle 7, if I use 47 degrees as my angle, I only know one side. That's this one. So I'm going to have to use that. And then the side I'm trying to find is B. So what sides do I have? 9 is what to 47? It's opposite. And what is B to 47? It's adjacent. Which trig function uses opposite and adjacent? It's the tangent. Okay, it's the tangent. So the tangent of what? 47. So this time I know the angle. Okay, I'm not trying to find the angle. I know the angle. Is equal to what? 9, which is opposite, over adjacent, which is B. Now I got to get B by itself. Well, look where B is. It's down here on the denominator. Where do I want it? I want it in the numerator. So I'm going to put it on the other side. So I'm going to multiply both sides by B. See if we can do this in our head. Okay, let's try to follow. I want to take this B, put it on the other side. It's going to be on top. Okay. Then I got to get rid of the tangent of 47. What am I going to do with that? I'm not going to take the inverse because the tangent of 47 is an actual number. I could put in a calculator, get a number. So I got a B over here. What am I going to do with that tangent of 47? Divide it, so that's going to go on the bottom. So what do I have now? I got B equals what? 9 over what? 45. Is that what you said? Tangent of 47. Not 47, but the tangent of 47. See what I just did? I took that B, what's on the bottom, I put it on the top on this side. Took the tan of 47 on the left side that's on the top, and I put it on the bottom of the other side. And now I can just put that into my calculator. Again, make sure you know how to do that. Practice it right now. Get the calculator out. Put it into a calculator and see what you get. 9 divided by 47 tangent equals 8.39 or 8.4. I've been putting equals here. Technically, I should put squiggles. I'm not going to mark it wrong if you don't, but technically I should do that. Right here I can put equals because that's exactly 43. This is approximately 8.4. Okay, that's why I put the squiggle equals, the wavy equals. All right, let's solve for C. Let's use that same angle. All right, might as well. So now what do I have? I got opposite and I have, what is the C? Hypotenuse. Which one uses opposite and hypotenuse? The so, right? Which is the sine. So I'm going to go, the sine of 47 is equal to the opposite over the hypotenuse. 9 is the opposite, hypotenuse is C. My algebra is exactly the same as what I did before, right? Because the C is here on the bottom. So I'm going to put it on the top here. I'm going to take the sine of 47, put it on the bottom. So that means that C is equal to 9 over the sine of 47. Put that in the calculator. you should get 12.3 if you round it. 9 divided by 47 sine equals 12.305. Yep, 12.3. Again, please make sure you know how to use your calculator when you do these, okay? Because if I used a graphing calculator, I'd do it a little different. On my calculator, I got to hit 47 first, then I hit sine. On a graphing calculator, you hit sine first, and then you hit 47. Everybody understand that? All right. Only 3 more, right? Everybody getting a A+ so far? All right. Again, the numbers could be different, but still kind of the same. Now this one, they don't give you a picture, but they do tell you have a right triangle. Okay, so it says solve the right triangle. And then they give you some given measures. They say A is, let's see, I'm just making something up. Let's say 13. Let's say C is 37. And that's it. It says round the answers to the nearest tenth. Okay? That's all they give you. And it says solve the right triangle. Solve the triangle. Well, let's draw a triangle. Doesn't have to be to scale. Doesn't matter. It's just a reference triangle. What's that? Yeah, this is the last 3. 8, 9, and 10. Now look, they give you little a and little c. They don't tell you this, but I'll tell you right now. What have they made C so far? Look what C was. C was the what? The right angle. Now this didn't have a C in it, but this one had a C in it. So where do you think our capital C is going to be? At the right angle. So let's make sure we do that. All right. Now, it doesn't matter which one you call A or B, okay, but we'll make the C the right angle. They should have told you. Triangle ABC. Yeah, I don't know. I must have copied it right from the books. That's probably what the book said. But it says little c is 37. So where is the 37 going to be? It's going to be the what of my triangle? Hypotenuse, that's right. Okay, everybody with me? Now, it doesn't matter which one's the A or B. We'll put A here and B here. So what's the side A? Go ahead. Yes, exactly right. Yep, I was about to say that when I asked where's little a. So little c would be 37 because why? It's across from or it's opposite big angle C. What about little a? Where's that going to be? It's going to be opposite angle A. So this would be the A right there. So that would be 13. What else do you think I have to find that I don't know? Should be 3 things, right? I need to find angle A, I need to find angle B, and I need to find what? Little b, which is side B, which would be right there. Again, make sure you put that little b across from the capital B, little a across from the capital A, little c across from the capital C. Everybody got that? So what are we trying to solve for? Let's move this over. Give some room to write. So this would be, what I say, 8, 9, and 10? So that's 8, 9, and 10. So let's solve for angle A. Let's solve for angle B. And let's solve for little b, or side B, right? What do you want to do now? I don't know any angles at all, do I? So which angle do you want to find? You want to find A or B? What's that? Or I could find side B. I could find side B right away, couldn't I? How could I do that? Pythagorean theorem, okay? So let's do it. These are different numbers than I have written down, so we got to do it. So what do I got? B squared plus 13 squared equals 37 squared. To find B, watch, B squared equals what? 37 squared minus 13 squared. Then you take the square root, don't you? To get rid of that squared right there. So we put that into a calculator. Again, we're going to round everything to the nearest tenth. So I go 37 squared minus 13 squared equals, take the square root, that's 34.6. If I round it to the nearest tenth. 34.6. So that goes right here. So I didn't have to do any trig at all to find side B, did I? Now, it's not drawn to scale, is it? And we don't care. Again, it's just a reference triangle, right? Just to see what side's opposite what angle and all that kind of thing. Right? Because there's no way that's 34.6 if that's only 13. Agreed? So really, this would be really short and this would be really tall in reality, right? But we don't care, okay? Because we just want to find what the numbers are. Yeah. No. It says round it to the nearest tenth. Okay, so yeah, this does come out to a 1200, all right? So you could simplify the radical, but they ask you to round it to the nearest tenth, so I'm just going to put it into a calculator, not even worry about rounding the square root, okay? Or not rounding the square root, but simplifying the square root. Everybody good? All right, what about A and B? Let's do B first. So what are you going to use? Now, you know what side B is 34.6, but do you want to use 34.6? No, because it's an approximation, okay? Let's use the exact numbers that they gave us. Let's use this side and this side. So what is this side right here to this angle B? This is adjacent. What is the 37? It's hypotenuse. Which trig function are we going to use? It's the cosine, all right? It's the ca. That's how you remember it, but we say what? The cosine. So let's do it. The cosine of this angle, which is what? B, is equal to the adjacent over the hypotenuse. 13 over 37. Now we got to solve for the angle. How do we get rid of that cosine? Angle B is what? The inverse cosine. Remember that? Okay, we did it in one of the first examples. So you have to get rid of the cosine. You don't divide by a cosine, but you can take the inverse of the cosine. And then it's the inverse cosine of 13 over 37. Now, it's just all calculator. So let's go 13 over 37 equals 0.35 blah, blah, blah. I'll keep that number right there, then hit second function cosine, and I get 69.4. So this is 69.4 degrees. All right, that's this angle right here. Now, technically, you could just go 90 minus 69.4 to get this angle right here, couldn't you? All right, but just for the fun of it, let's do some trig. How do we do that? Well, again, use the same two numbers that they gave us to begin with. Let's use the 13 and the 37. But what trig function are we going to use? We use opposite over hypotenuse. Which one's opposite over hypotenuse? So, which is the sine. So we take the sine of angle A is equal to the opposite over the hypotenuse. Like Mr. Hamrick, that's the same thing as this one right here. But is it the same thing? No, because this one we're doing the cosine. This one what? We're doing the sine. Everybody got that? All right. So what's A equal to? A is the inverse sine of 13 over 37. Put that into a calculator. This time we're punching in sine instead of cosine. So it's 13 over 37, and that's point. Oh, it's going to be the same. No, actually, I'm sorry. Second function sine. So it's about 20.6. And it's in degrees, so that angle right there is 26. That's supposed to be a degree symbol. 20.6 degrees. That doesn't look like a degree. And that's the same thing if you went 90 minus 69.4, isn't it? 90 minus 69.4. Yeah, it's 20.6 degrees. So you could have done it either way. You could have just gone 90 minus 69.4, or you could have done the trig, and you got the same exact answer. And there you go. There's your quiz. Everybody gets 100. Yay. Let's hope. Nope. Any other questions on this stuff? So coming back to you now? Yeah. A week wasn't that long, right? You don't forget too much in a week. You remember SOHCAHTOA, right? That was the important thing to remember. SOHCAHTOA. What? You forgot it already? We said it up here. Right there. SOHCAHTOA. Right? You remember that, right? It's weird when I said it. SOHCAHTOA. How's that? All right, enough of that. I think that's good. That's the quiz. That's going to be tomorrow. All right, so be ready for it.